Welcome to another episode of our virtual cosmic journey. In this video, we'll explore the habitable zone of the Milky Way, where life generates, and the Galactic Disc, a region of high star count and interstellar gas. Life in the universe certainly seems like a fairy tale. There were only aliens and their UFOs have been associated with extraterrestrial life. But now the truth has been out. Our galaxy, the Milky Way, is much more than we grew up studying. It's an intriguing creation of nature designed to stun you from every corner. Amongst many wonders, the Galactic Habitable Zone is one of them. It's a region around the star with the perfect temperature to generate life. The habitable zone has the right temperature to have liquid water on its surfaces. As we see the significance of water for biological life, this shows there are suitable chances of having conditions for life to start. The Milky Way is also home to the groundbreaking site of the Galactic Disc, where all the massive and small stars hang out freely. Within the disk, the stars dance like a cosmic bullet with the tune of gravity. So, without any further ado, let's see what this Galactic Habitable Zone has in store for us. Our Milky Way galaxy is far more unique than most of the galaxy systems in the universe. It's filled with wonders, mysteries, secrets, and extremely vivid details one could never think existed far away from the Earth's surface. The habitable zone is also one of those wonders that blew up the entire scientific community. Imagine it as the sweetest spot in the bone camping that's neither too hot nor too cold to freeze. Just like that, this zone is known to have the perfect amount of temperature, not too cold, not too hot to generate biological life. Thus, we have named it the Goldilocks zone. Its right temperature helps it to have liquid water, since it would evaporate the water if the temperature is so high, or freeze if it's too cold. As we said earlier, it's the sweetest spot for planets where things aren't too extreme. However, the habitable zone's eccentricity depends on several factors that make the potential high to give birth to more planets. For example, the distance of the stars, either it's too near or beyond the reach of the naked eye. The type of star matters too, as some stars are hotter or some are much cooler. And last but not least, what material the planet is composed of also counts. The way the Milky Way stretched is pretty complex and similar to billions of other spiral galaxies. It's home to a number of interstellar matters like gas, dust, and young intermediate star. There are other trillions of stars in the Milky Way, and some are more metal-rich than others. For instance, the Old Age star tends to have more poor metals like hydrogen, lithium, and helium. These rich metals further fuse the nuclear reaction, forming the next generation of metal-rich stars. Surprisingly, our Sun is also considered among the metal-rich stars, but the Galactic Habitable Zone doesn't allow the ones located too close, and it seems to have a nice distance about 28,000 light-years. Though this restriction comes with benefits, since being situated far from the birthplace zone saved the galaxy from the gravitational tug of stars clustered near the galactic center. Just in case the distance was closer, it resulted in huge gravitational disturbances caused by the stars that would send massive comets in our direction, ending up wiping out the life on Earth. Also, being located far from the habitable zone also has some additional benefits. It saved us from the harmful radiation like gamma rays, X-rays, and cosmic rays, which would destroy any life trying to evolve on a planet. Moreover, the spiral arms of the Milky Way are the birthplace of new metal-rich stars, but it would be dangerous for our solar system to cross this region. Thanks to nature, our Sun orbits with the same speed as the spiral arms that help prevent it from crossing it. Even Gonzalez said, "At our location, our orbital period is very similar to that of the pattern speed of the spiral arms. This means that the time interval between spiral arm crossings will be a maximum, which is good since spiral arms are dangerous places. Massive star supernovae are concentrated there, and giant molecular clouds can perturb the Oort cloud comets, leading to more comet showers in the inner solar system." However, Gonzalez also argues that the Sun has a lot of unusual characteristics that make it possible for complex life to emerge on Earth. He said that over 95% of stars in the Milky Way, which is our galaxy, can't have planets that are good for life. This is because these stars don't dance along with the galaxy's spiral arms. Also, it's worth noticing that there are millions of other factors that contribute to finding the solar system in the habitable zone, and it is not less than trying to find a needle in a haystack. The habitable zone, galactic bulge, galactic center, and now the galactic disk, all these systems are the wonders of the universe. Coming to the galactic disk, think of it as a huge playground in our Milky Way that's flat or, more likely, a spinning part of a frisbee. When you gaze upon the sky at night, you don't look at the sky basically, it's the galactic disk where all the exciting phenomena happen. If you consider Milky Way as a gigantic spiral painting, the disk is where all the spiral arms are, just like the canvas that holds beautiful spiral sights of the universe. It's the component of disk galaxies such as spiral galaxies, lenticular galaxies, and the Milky Way. It consists of stellar components like most of the galaxy's stars and gaseous components like cool gas and dust. The stellar population of the galactic disk seems to have little to none random motion because most of its stars orbit the galactic center in close circular orbits. It is also known to be pretty thin since all the components lie predominantly on its plane. There is approximately 1 Cly of thickness in the Milky Way's disk, but other galaxies' disks may vary in thickness. Within the disk, there's another huge world of stars that are fully crowded and come in all kinds of big, small, hot, and cool, a real mix of stellar personalities. When we delve deeper into the galactic disk, groundbreaking sights like nebulae exists. These nebulae are like cosmic cradles where new stars are born. They're made up of gas and dust, which slowly come together under the pull of gravity to form baby stars. Though the formation of stars isn't that quick or simpler, it actually takes ages to form a metal-rich interstellar body after years of gas and dust floating in space. When these particles pull closer with gravitational force and clump together, they create pressure and heat at their cores, just like dough becomes puffy when you bake it. The intense pressure makes the gas and dust glow heavenly brightened, and eventually a star is born. All these formations of baby stars occur in the spiral arms of the disk, making the sight more and more exciting to observe for the scientists. However, you may think the stars just hang around not moving, but that's not the truth. The stars do move around their specific axes. Some stars move faster, some move slower, and some even change their paths over time. It's like stars are taking a journey through the cosmic city. It's also worth mentioning that the star's movement actually helps us shape the cosmic landscape. When one star passes by, gravitational pulls occur, resulting in the swapping of the axis with another stellar body. This movement changes how the galactic disk looks and behaves over millions of years. Between the formation of new stars, interstellar gas is also something invisible but very important. The gas is what actually helps hold the galaxy together. It also plays a significant role in clamping the stars together under gravity to create new star nurseries. They're not empty spaces but cluttered star factories. Gravity can work its magic inside these clouds, bringing gas and dust closer together until new stars are born. Scientists and astrophysicists are actively searching for signs of life on planets in the habitable zone. They search for biosignatures proving that life might exist in these zones. This could include things like certain gases in a planet's atmosphere. Researchers use special tools to discover how stars are born in the disk. They track their movement to help understand the dance of particles that actually led to the next generation metal-rich stellar bodies. Tracking their movements will also help them piece together the history of our cosmic neighborhood. So, let's end the video here. I hope you enjoyed the virtual cosmic journey to the habitable zone and the galactic disk. Don't forget to share your views in the comments.